I've had a pretty wonderful 2 days. And just a minute, I need the clicker, please. I've had a pretty wonderful 2 days at Web Summit. But I've been searching for all the crazy things that I've found. In the last 2 days, apart from the colored sheep, I was talking to some people and they said, hey, you know what? How often do you attend those crappy meetings where you're bored and you don't have anything to do? So he actually convinced me about an anti-crappy meeting survival kit. An anti-crappy meeting survival kit. I mean, it makes you rethink a crappy meeting. And that's exactly what I'm here about. Another example is how you have to rethink the way we all do our daily chores or the way we code. If I ask 5 people, maybe 10 people, maybe 15 people, how do you pronounce my name? I'm probably going to get a lot of different answers. But if I give you a direction, like for example, my first name is Gautam. Gautam with a twist. And my last name is Rege, the music genre, but no relation. Now at the end of my talk, if I ask you what my name is, I'm pretty sure you will not forget because you've got a direction to go in. Now, that's what we're going to do today. Rethink the way we program. And why Go? Because it goes back to the 70s. Think about a case where we can go back in time, redesign the way languages were made, get rid of all the stuff that we don't like, keep all the cool stuff, and make things better. Now, I know it's a varied audience. It's going to be, the demographic here is huge. So there are going to be some people who are experts in code. There are some people going to be who don't know any code at all. So I kept my presentation with a lot of cartoons. So for those who don't enjoy code, enjoy the cartoons. And yeah, we're going to have a lot of code samples. It's Code Summit after all. Well, little bit about me. Another way to rethink how you pronounce that. It's not Josh, it's Josh because I'm an Indian and I have a company in India for the last 8 years. Josh Software has been doing a lot of Ruby on Rails. Recently fell in love with Go, and that's what we do now. But the big question arises, what is the need for just another language? Now, how many languages have you seen which have a really cool mascot? The best way to make a language popular is to design a really cool, nice mascot, build various cartoons and caricatures around it, and promote the hell out of it. Well, I'm joking, but of course I'm joking. But back in about 6 years ago, in about 2007 to 2009, Rob Pike, Ken Thompson, and Robert Griesmer, they were sitting in Google and they needed a language which was going to solve a problem for them, which is going to be fast, which is going to be safe, and which is going to be easy to pick up, maintain, and learn. In 2 years, they did exactly this. And of course, no points for guessing what they came up with. They came up with the Gopher and said, all right, now we have a mascot, let's build the language around it. So once the language got built, it gets the best of systems programming language. It gets the best of all the constructs that are available. And it gets out the worst of what there is. The roots of Go back a long way. Please note, Go has been inspired by no language which is in the 80s or 90s. Very few of them. The primary source of inspiration for Go has been C, Smalltalk, Newsquik, CSP, and stuff like this, which is way back in the olden days. To put it very simply, C on steroids is what I call Go, right? Now, what are the problems we faced when we are programming in C? We have the pointer, the dreaded pointer, which everyone's afraid of because there are memory leaks. Well, Go has its own garbage collector. So now you no longer have to bother about your memory leaks. You also don't have this dereferencing issues of an arrow or a dot and you think, and somebody else comes and makes a small change. All this stuff is gone. Go supports higher level constructs like maps, hash maps, slices, closures. And it goes the distance to be pretty fancy because coding is an art. You always want your code to be well formatted. You want your code to look good irrespective of which editor you use. And you need to get dependencies from the net. You should be able to install things. Hell, they even got a tool, GoFix, which will, if you have an upgrade in Go and it requires some syntax changes in your code, it'll go fix all your code for you. But the biggest power of Go today is the power to utilize multiple codes in a higher level language. Now, quickly before we look at this, we need to realize that concurrency and parallelism are two different things. Concurrency deals with things happening independently. Parallelism is doing things at the same time. And here's a good photo of Rob Pike, Commander Rob Pike. He says, when you want to communicate between different processes or interoperate, communicate by sharing. Don't use shared memories, and this is a new concept. But of course, I could go on and bore you guys with this. Why not actually see the power of Go? Now assume I have 4 concurrent tasks running, each doing its own churn, some heavy duty churn, but they must complete in order. In effect, we can consider this a relay race of 4 tasks going on together, and when they finish, they need to wait for the previous leg to complete. Let's see how this goes. Here, I have this screencast where I have code which is doing some severe, massive CPU churn. As you can see, I've highlighted there. And when I run this code, I'm going to just run, you can see there are 4 legs which are churning. And I'm going to see how much CPU is being used. Understandably, 100% CPU because I'm in 2 for loops. So far, so good. Now, it is important to realize that each leg has to complete one after the other. So maybe leg 2 or 3 will complete beforehand, but they have to wait. As we'll see now, it's running on 100% CPU. So leg 2 completes but waits for leg 1 to complete, and then all of them complete, and so far so good, no problems. I change one line in the code, the last line there, and says, hey man, use all the codes that you have, and let's do the same thing again. However, the first change I see that they're already got ordered differently. The second change that I see is once I start seeing how much CPU is being used without having to do anything, my program's running at 300% already. It's already started utilizing all the cores. And in fact, this stuff is visibly faster than last time. It's already over. The program's already run faster. Now, what is the takeaway from this particular screencast that y'all are seeing? For the keen-eyed, the keen-sighted, if you see the number of unread emails I have in that, you should probably realize never to send me an email. But getting serious about Go. All this stuff is based on a new cutting-edge technology called communicating sequential processes, state of the art, been there in the industry since 1978. Where were we? The world took a turn in a different direction, and we forgot that we could actually do something so fast. Now, being in the modern world, we always want to know, hey man, you're talking about C, you're going back to basics, but is Go object-oriented? No. It's like C, but it supports all the features that are there, and we can simulate and make everything in Go look like object-oriented, but be the true object-oriented stuff. And lo and behold, our first snippet of code. The first thing that stands out here is, hey, I don't see int I anymore. I first write the name of my variable and then define what it is. So I say name is a string. For example, people is an array of pointers of attendee. I write it the way I read it. The other thing we notice is
Some start with a title case, some start with a small case. Access specifiers, public, protected, and private stuff that is there in object-oriented stuff. If you have it starting with a capital letter, it's an exported variable or an exported function. If it is a small case, it's not exported. And of course, Big Brother's always watching, there's nothing protected. Well, let's move on. The other thing that we see in this particular case is what is this attendee thing that is there? Attendee here is the way we do inheritance with embedded structs. Now, a speaker is also an attendee. So a speaker also has a name. So I can easily access the name by saying .name. I don't have to reference it all the way. But now a common question will arise, what happens if I embed two structs having the same exported variable? I can also give it the complete reference check, and it can actually work. Well, so we've looked at access specifiers, we've looked at inheritance. What about the real object-oriented stuff? Go has functions which accept receivers. In the first method, I'm writing a method for a pointer to a conference. In the second method, I'm writing a method called attend to a pointer to an attendee struct. And there I'll call a method on an object, simulating object-oriented stuff. Now, the interesting part here is I have multiple returns from a function. This is not analogous to things like returning a tuple or an array from a method in, say, Python or Ruby, because that's still just one data type. This is actually returning different values from a function, which means that I can pass or return an error from any function. Hey, I don't need exceptions anymore. There are no exceptions in Go because an exception is just another form of an error. And if I can pass return values along with an error, why do I need exceptions anyway? I hope you're also liking the Gopher cartoons that are there coming along. It took me a lot of effort to find so many of them, figure out that they're in Creative Commons, and then use them here. Wow, interfaces. The entire concept of interfaces has been misconstrued over a long time. We feel interfaces are a top-level design, but honestly, in reality, interfaces happen. Now, I can be angry and sad and happy at different times, but it's me. So when I work with some struct and which shows the behavior, it should actually be an interface. So in Go, you don't have any particular way of implementing an interface. In this particular example, a conference and an attendee both could have a social handle. If both of them are on Facebook and on Twitter, all right, they're automatically the social network interface. And the earth rotates, and a top rotates. I don't actually have to specify when the earth that it should implement a rotator interface. I don't need to tell the top. I just tell them to do their own stuff, and we'll generalize later on. How does this help me? Polymorphism. I can take a reference of an interface. At one time, it's an attendee struct. The other time, it's a conference struct. Now, we've looked at almost all the various aspects of object-oriented stuff along with Go. But this is something that brings us to a completely different realm. How does Go help me rethink programming? How does it make me a better programmer? For example, it's a common thing, and I borrow from Douglas Adams here. I love the SEP. It's not my problem, somebody else's problem. When you face a problem in your code, something's not working, dude, the easiest thing, just blame the compiler. Oh shit, the compiler is pretty good. All right, let's blame the reviewer. Damn it, he's my good friend. Well, let's blame the framework, the libraries. They're working too. All right, let's just blame the language. But it's not my problem. It's always somebody else's problem. Well, it's a thing in Go that if you're able to compile your program, if your program compiles, it's most probably just going to run correctly. Now, having said that, Go is a statically typed language. It is compiled and has no other dependencies on any other bindings or libraries. For example, when you're working in Java, you need the SDK, you need the JRE. When you're working in Ruby or Python, and these are just common examples I take, you have to have the interpreters installed. In Go, you compile your code, it compiles into a binary which will just work on that architecture. So, in Go, it also helps me, even though it's statically typed language, I can implicitly define a type. Now, in this case, y is implicitly of type int. And then I try to assign a string to it. The compiler will complain saying, hey, you don't want to do that. There is better ways to do it. If you really want to convert an integer to a string, use a2i. There are methods for this. Simple, straightforward. But here's a little more complex part where I'm actually getting down to how I should program, not how I want to, but how Go tells me you should be programming. For example, this is also a construct of how I create a map. Now, we have maps and we have arrays. Typically, maps are for lookups. So should you ever iterate over a map? The idealists say you should not ideally iterate over a map. If you wanted to iterate, it should be an array. And if you do end up iterating a map, Go will tell you that, hey, you shouldn't be doing this. In spite of this, if you want to, I want to ensure that you don't rely on the order of insertion. So it will randomize the order in which you iterate the hash. This will automatically ensure while you are coding that you are not going to use the wrong data type for the wrong work. Well, Go also has defer. As usual, defer will run whenever the program exits or the function exits. And it will clean up or do anything. So no more lost files, no more open files. But let's get back to the good stuff of Go. We've already seen this example of 4 tasks and the running in them. These 4 circles or tasks are called Go routines. Now, Go routines are not threads. They are Go routines because they're different. In one Go program, I can spawn up to 200,000 Go routines. They all multiplex over system threads, and it seamlessly does a context switch, which helps me run a lot of code concurrently. Communicating between them is done using channels. And what better way to see this than to actually see the code that we've actually seen? We've seen this code run before, but let's have a look at it in a little more detail. This is what a simple Go program looks like. I have a package main. I can import different functions or libraries. I have a wait group, which is like a join for threads. It's the same thing. I'm going to have a wait group, which is much easier. I'm going to look at some code and see this is how I make a channel. A channel, in this particular case, is exactly, it's an ideal example because it's like a baton. I am passing on to somebody else. I'm going to block till somebody takes it. And when somebody takes it, I continue running. So I have communicated by sharing some resource. So I've shared something, and I'm communicating. This is exactly how a channel works. A good way to remember a channel is by using the example of a baton. Well, this is how you spawn Go routines. Just prefix Go behind the method, and you're done. So when you're testing your code, when you're writing your code, you don't put a Go routine, just test it. And when you want to parallelize it, when you want to make a lot of things run in parallel, just add Go behind it, it'll automatically spawn a Go routine for it. I can write and read from a channel. I can do a lot of things like standard for loops and stuff in Go. Hey, you can see a use of defer here. And I can read over, I can range over a channel. I can keep seeing, is there anything for me? And this particular code is, when it's trying to see, is this particular channel writing something for me or not? And that's about the lines of, that's about the code that you see, which tells you a lot about how Go really works. Now, who uses Go? If you all have used Docker for deployments, you're already using something that's built in Go. A lot of companies have started using Go. These are all the these are all the big companies which have already been looking at Go for a long time. And it is my inference that Go is going to be the language of the next decade because it's a general purpose language that's going to go a long way. No pun intended. What do we use it for? We're currently building a smart city technology platform for which we're going to give a lot of functionality, a lot of devices. There's so much variety in this that we need to have some sort of uniformity. It's not just software, it's also hardware devices and fancy looking microbots all over the city. Each one having devices in them. And these devices are talking to different protocols. These devices are talking on different networks. And we all need them to actually get into a single repository where we can churn data into analytics. So Go helps us out in ensuring standardization of code everywhere and working with even different architectures. This is like PIC32 architecture, so it's like really low-level stuff. This is a kind of what it looks like. And you can see that just from your phone, you can actually control the entire electricity meter in your house, start it and stop it. Once your electricity meter actually comes down to 0, it actually stops. This is communicating from your phone to the net, to the device, going back to the electricity meter, talking Modbus, cutting off your electricity, coming back all the way. The same way you can control a lot of utilities. How do we know Go is getting popular? Why, of course, so many different types of Go cartoons. There are conferences happening all over the world. These conferences are very specific to Go, and there are a lot of companies which are supporting Go in this. Go also has a lot of references, which we can look. Everything about Go is open source, and it's being controlled very well in the open source realm. You can see this by going to any of these sites and starting from here and drilling down deep. Documentation plays a huge part in this. Formatting of code plays a huge part. And these are the things which actually help us get going. So let the Gophers begin. Do we have time for questions? Because thank you very much for your time and listening in.